Let us now look at the metabolism of vitamin D and how it is related to our calcium metabolism. We have two sources of vitamin D, the dietary source of vitamin D and also the vitamin D that is manufactured through the action of sunlight on our skin. 7-dehydrocholesterol is a precursor made in the liver from cholesterol, and this by the action of ultraviolet light from the sun which falls on the skin is converted into a pre-vitamin D3, and from the dietary sources also we derive this pre-vitamin D3 which is an inactive form. The supplements that we take in the form of medications are usually vitamin D2. This vitamin D2 is again converted in the liver into the inactive form of vitamin D3, which is the 7-dehydrocholesterol converted into the vitamin D3 or the supplemental vitamin D2 converted into vitamin D3. This vitamin D3 molecule, the inactive form, for it to have any action on the gut to absorb calcium and phosphate requires double hydroxylation. Let us say that vitamin D3, this is a check which will be presented at the gut for the absorption of calcium and phosphate. This check requires two signatures by two officers. The first signature is the hydroxylation at the level of the 25th position of the vitamin D3, which is done by the liver. So, the liver is the first officer which signs the hydroxylation at the level of the 25th carbon atom, and then that 25 hydroxy vitamin D3 is carried on to the liver, onto the kidney for a second hydroxylation at the first position. So, the second signature on the check of vitamin D3 will be signed by the kidney, and that is the second hydroxylation at the level of the first position. Then the vitamin D3 becomes 125 dihydroxy vitamin D3. This 125 dihydroxy vitamin D3 is also known as calcitriol, or which is the active form of vitamin D3. So, either the 7-dehydroxycholesterol which is under exposure to ultraviolet light, or the food source of vitamin D3 or the supplemental vitamin D2, all of them have to be activated first in the liver at the 25th position, next in the kidney at the first position, so that the 125 dihydroxy derivative is produced, and which is the active form of vitamin D3 called the calcitriol. Only this active form is useful for us for calcium metabolism. This active vitamin D3 is recognized by the gut as a valid check, and then in the gut the calcium receptors will be activated and they will accept the calcium in the diet and in the supplements, and then send that calcium into the bloodstream. Likewise, phosphate also is absorbed in the gut under the influence of the active form of vitamin D3. This is to just reinforce what we have seen in the previous slide. Formation of the calcitriol or the vitamin D3 active form. Vitamin D is a steroid hormone, either from the dietary sources or from the action of sunlight on the skin. It requires successive hydroxylations of this cholecalciferol. The first hydroxylation occurs in the liver, 25 hydroxylation, and the cholecalciferol is converted into 25 dihydroxy cholecalciferol. This 25 hydroxy cholecalciferol is further hydroxylated at the level of the kidney in the first position, and that becomes 125 dihydroxy cholecalciferol, which is also known as calcitriol or active form of vitamin D3. We have already seen that the calcium homeostasis is maintained by three important hormones: the parathormone, the active form of vitamin D3, and the calcitonin. The parathormone is secreted by the 4 parathyroid glands which are on the back of the thyroid gland. Tiny pea-sized 4 parathyroid glands are there. This parathormone is a 84 amino acid hormone. Low calcium in the serum stimulates the secretion of parathormone so that the bone resorption occurs and calcium is brought from the bank, the bone, and deposited in the serum. The main action of parathormone is on the bone. Whereas calcitriol or active form of vitamin D3, how it is formed we have seen in the previous slide, and this active form of vitamin D3, it helps in the active bone formation. The main effect of course is on the gut, and in the gut the vitamin D3 facilitates the absorption of calcium and phosphate through the calcium receptors. Of course, parathyroid hormone increases the activity of vitamin D and thus indirectly influences the absorption of calcium at the level of the gut. So, if you look at calcitonin, calcitonin is a hormone secreted by the parafollicular C cells of the thyroid gland. It is a 34 amino acid hormone and its main action is on the kidney, and we have already seen its main action on the kidney is to send the calcium out, that is to increase the excretion of calcium and phosphate at the level of the kidney. These 3 hormones thus maintain the homeostasis of calcium. Let us now grade the hypercalcemia. Before we grade hypercalcemia, we must know what is the normal serum calcium level. It is in a very tight narrow range of 8.5 to 10.3 milligrams percent. Remember, I am talking about the total serum calcium and not the ionized calcium. The ionized calcium is usually not measured, it is difficult to measure and it is not available in all the laboratories. So much so we have to work out only the total calcium including the ionized calcium, and that is 8.5 to 10.3 milligrams is the normal value. We need to apply the correction depending on the albumin level which we have already seen. So, if the corrected calcium is between 8.5 and 10.3, then we can say the patient is having normal serum calcium. If the serum calcium is between 10.4 to 11.9 milligrams, it is a state of mild hypercalcemia. Usually this mild hypercalcemia is asymptomatic and it is only seen, observed and detected by screening the serum calcium. 12 to 14 milligrams percent is moderate hypercalcemia, usually symptomatic, requires treatment, requires vigorous treatment. And more than 14 milligrams of serum calcium is called critical serum calcium or critical hypercalcemia, and this requires admission and very intensive treatment to bring down the calcium much below the 14 milligrams level, so much so the cell membranes are protected and the cell electrical activity is maintained. Otherwise, patient may end up with cardiac arrhythmias and we may lose the patient. So, these are the 3 different grades of hypercalcemia: mild hypercalcemia 10.4 to 11.9, moderate hypercalcemia 12 to 14 milligrams percent, more than 14 milligrams critical hypercalcemia. Remember, all these values are adjusted to the albumin level using the correction formula which we have already discussed.